Hi, welcome back everybody. We are going to be talking about matrix multiplication today. This is probably going to be one of the easier lessons, hopefully. It's not, right? It's just multiplication. How scary could it be, right? Raises eyebrows, right? But this is not multiplication like normal. We're going to do multiplication and adding. You're going to have to do two different math operations today, which I understand can be a little frustrating sometimes, but that's okay. So we're going to learn how to multiply matrices. We're also going to talk about what conditions are required for you to even be allowed to do that. Because you can't just take any matrix and multiply it to any matrix. It doesn't work that way. So we'll kind of talk about what is a matrix, when can I multiply them, and how do I multiply them. So first, let's start with what even is a matrix. So a matrix is a way that we can represent linear equations in an easy to manipulate way. This is a little unintuitive at first. It can be a little challenging to try and figure out what this even represents. But once you get used to it, it's actually, it lets you do math a lot faster than if you've got all the extra stuff in there that kind of just takes up space. So let me give you an example of where a matrix like this could come from. Let's say you've got something that's $3 per bag of chips, and you've got something else that's $2 per bag of different kind of chips, and those equal something, right? We'll say 18 bucks. If you have some other equation where it's, here they cost $4 for that bag and $8 for the other kind, well, now they equal some other number, let's say like 48, right? What we do is, because we have the x's and the y's in all the same spots here, it's kind of a waste of time to write them out. So what they do is they just take these coefficients and then they throw them into a matrix like that. If we wanted to include this, we could have what's called an augmented matrix, where there's a line here and then they put what the answers are. But we're not going to mess around with augmented matrices today. They're useful for solving systems of equations, but they are not necessarily what we want to focus on. So we're not going to get distracted by augmented matrices. So what I mean by linear equations, you can see this is x to the first power, y to the first power, first power, first power. It just means all these variables we're kind of ignoring. We're saying, all right, here's the y's, here's the x's. Because these are all in the same spot, I know these are all x's, and I don't need to write an x next to them. It's just to save space and condense it so that we can do some stuff to it. Cool. So that's kind of why you want a matrix. These are super applicable in computer science. And what computer science is like coding, programming, software development. A lot of times if you work for, let's say you work for the school district and you do programming for them, a lot of times you'll have tables where it'll be like, here's everyone's name, here's their phone number, here's their ID number, right? And then it'll have like Jose phone number ID, Maria phone number ID, Thomas phone number ID. And you need to manipulate these things. So you can do stuff with matrices, because this thing is basically a giant matrix. So this thing is probably one of the most useful maths for doing really large scale things in a manageable way. You would never want to try and do something for Amazon's logistics team where you're looking at like thousands of variables at once without matrices, because it would be too cumbersome and too ugly to look at. So they make really long repetitive tasks a lot easier for us. Okay, don't let that scare you though. We're gonna stick to little tiny matrices like this because we're still in little tiny kid math, right? We're in high school math. We're not going to work for Amazon anytime soon. So, all right, so let's talk about just some vocabulary of matrices so that you know what we're talking about. And then we'll go learn how to multiply and when to multiply. So just so you know what a row is, in case no one ever told you how to tell the difference between a row and a column, a row is the group of horizontal numbers. So this is a row. This is a row. So rows are the horizontal groups. They are numbered, so this would be row 1, row 2, row 3 if we had another set. Starting at 1. Okay. Columns, I bet you can guess. Don't look. My dumb self just put my hand over this word, right? I was like, ooh, I've got real pointy fingers, huh? Yeah, I put my hand over it like that, but you couldn't see my hand because, I'm screen capturing. But anyway, columns are the vertical ones, so these, and we number them left to right, so 1, 2, 3. The most useful thing anyone ever said to me to remember the difference between rows and columns, if you look at Greek architecture and you're like, Barton, what the heck does that have to do with anything? This thing right, these things that you see in Hercules, these things are called columns, like columns of the Parthenon and whatnot. And these things go up and down. So up and down is columns. I don't know. And someone told me that in like middle school, and now that's how I remember what columns are. So hopefully in like 30 years when your kid's like, Mom, Dad, what's a column? Just point at one of these things. Columns go up and down, kid. Okay. The last thing we want to talk about is what is the order of a matrix. So the order is how we say what the size of a matrix is. This is written as columns, and then this is a little like cross. It's not a multiplied by. Columns by rows. So, holy smokes, you guys. I can read, I swear. Rows by columns. I double checked this, so read the words on the screen. Don't listen to the words I'm saying. Rows, the little cross means by columns. Okay, so we have 2 rows and 3 columns here. So this would be a 2 by 3 matrix, just so we're clear. Okay. This idea of order is going to be super important for us because order is how we determine are we even allowed to do the matrix multiplication. All right, so let's go talk about the rules for multiplying matrices first, then we'll go look at a couple examples. Okay, so to be able to multiply 2 matrices together, the number of columns of the first matrix must match the number of rows of the second matrix. So let's go write down the orders of these real quick. This is a 2 by 3 matrix, and this is a 3 by 2 matrix. Okay, so the number of columns of the first matrix, that's 1, 2, 3, must match the number of rows, 1, 2, 3, of the second matrix. So if you have an m by n, and these are just like placeholders, they're like variables. They could be any number you want. If you have an m by n matrix, you can only multiply that times an n by something else matrix. So when you're doing the multiplication, basically what you have to do is you have to make sure these inner dimensions match for the multiplication. You have to make sure the 2 inside numbers, when you write the degrees in the order of the matrices, the 2 inside numbers must match. If they don't match, you are just not allowed to even do the multiplication. It's forbidden, It's like that secret room in like the back of some ancient temple, right? And it's got a big keep out sign, right? prophets, visionaries, and Buddhist monks only, right? So it's just forbidden. You're not allowed to do it. So what that means in math, because it's just like, well, you can't do that. What you should say if you're not allowed to do the matrix multiplication is that it is undefined, right? There isn't a set way to do it. There's no definition. So it's undefined. All right. So let's go look at a couple examples just to like whet our palate and learn how to do this. Okay. So example number 1. The first thing we need to do for every single matrix multiplication is check the order of our matrices and see, are we even allowed to try and multiply them? So this one has 2 rows and it has 2 columns. So this is a 2 by 2 matrix. And we're trying to multiply that to a 1, 2, 3 by 2 matrix. So we can look, the inner numbers do not match here. So the columns of the first matrix don't line up with the rows of the second matrix. So we're not allowed to do this problem. You cannot multiply, it's forbidden. Mathematicians haven't set up a way for you to do that. So this is just undefined. There you go, you're done. Easy? Of course, Spartan, I didn't have to do anything. Perfect. All right, let's actually do one now. So of course we have to check the order. This is a 2 by 2. This is also a 2 by 2. So our inner numbers for our orders match. So we are allowed to do the matrix multiplication. So now let me explain to you how to do that. What we are going to do is we are going to take the row of this matrix and we're going to multiply it to the column of this matrix, and we're going to add those things together, and that's going to give us the first term of our new matrix. Okay, this is going to take a little bit of work, so we're going to put our new matrix over here and I'll fill it out after we do our simplifying. So to get this first term in our new matrix, I'm going to multiply the first number in this row by the first number in this column. So this is going to be 1 times 3. Then I'm going to add that to the second number in the row times the second number in the column. So -1 times -6. So 1 times 3 is 3, plus -1 times -6 is 6, and 3 plus 6 is 9. So this first number is going to be 9. Now, to get our second number, what we do is we move over to the second column. So I want the number in the first row and the second column. So I use the first row and the second column. And let's change color here. So I multiply the first number in the row to the first number in the column, 1 times 1, plus the second number in the row times the second number in the column, -1 times -2, positive 2. So 1 times 1 is 1, plus -1 times 2 is -2. 1 plus -2, that's -1. All right. Now I want the second row, so I have to use the second row. And I want the first column, so I have to use the first column. And let me erase some of this stuff just to clean that up a little bit. So we're looking at second row, first column, and you just go in order. So first number in the row times first number in the column, plus second number in the row times second number in the column. So 4 times -6. So this is 6 plus -24, and that's -18. So we put that there. All right, one more. We're almost there. I believe in you. Stay strong. What color do we want? I'm almost out of good colors. We've used, let's do blue, I guess, right? All right, so now we are doing second row, second column. So we gotta go over the second column. Whoops, hold on. Okay, second row, second column. So 1 times 2. Oh, I said that backwards, but oh well. So 2 times 1 plus 4 times 2. So 2 times 1 is 2, plus 4 times 2 is 8. So 2 plus 8 is 10. And then this is your answer. That's your final matrix. Cool. All right, so it's not hard, right? It's just multiplying and adding. It's just you have to be really careful about which columns and which rows you're using, and make sure you're putting the results in the right spots. Okay. Now, I can already hear you guys, but Mr. Barton, what if we have weird shaped ones, right? What if we have strange things that aren't just 2 by 2s? So let's look at a slightly more complicated one. And then we'll talk about how big should your final matrix be. So this is a 3 by 2 matrix, and this is a 2 by 3 matrix. Sorry for the pause, I can't talk and write at the same time. So we have to make sure our inner dimensions match. They do. Perfect. So we're allowed to do the multiplication. The answer, the new matrix that we make from this multiplication, its dimensions are going to be whatever the outer numbers are. So this will be a 3 by 3. Cool. So we're going to have 1, 2, 3, 1, 2, 3, 1, 2, 3. And I can already hear you guys moaning, oh, Barton, I don't want to multiply and add that many numbers. You're not. You're just watching. I'm doing all the hard work, so chill out. So we're doing rows of the first matrix, multiply it and add up everything with the columns of the second one. So this is going to be 2 times 1 is 2, plus 2 times 3 is 6. So that's 8 for the first one. Now we go over a row, or excuse me, a column. So now this is going to be, oops, come on. Okay, so this is going to be 2 times 2 is 4, plus 2 times negative 4 is negative 8. That's negative 4. Now we go over another column. 2 times 3 is 6, plus 2 times negative 1 is negative 2, so that'll be 4. All right, now we go down a row and repeat that whole process. So 1 times 1, here let's do a different color, let's do a red. 1 times 1 is 1, plus 1 times 3 is 3, so that's 4. Go over a column. Let me make that bigger so that we can see the whole thing. That way I get the negative in there. There we go. All right. So 1 times 2 is 2, plus 1 times negative 4 is negative 4. 2 minus 4 is negative 2. Go over a column. 1 times 3 is 3, plus 1 times negative 1 is negative 1. So that's 2. Now we go down to our last row, and we repeat our columns. So 3 times 1 is 3, plus negative 3 times 3 is negative 9. So 3 minus 9 is negative 6. Go over a column. 3 times 2 is 6, plus negative 3 times negative 4 is positive 12. So that's 18. And then last one. 3 times 3 is 9, plus negative 3 times negative 1 is positive 3. So that's 12. And then this is your answer for your final matrix. Okay. All right, and that's matrix multiplication. You are now masters of multiplying matrices together. Brief disclaimer. Here, let me add a slide. What you're going to be really tempted to do is if you have two matrices multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. What most students try and do when they see this is they try and just multiply corresponding elements And when I say element, I mean just one piece of the matrix. These individual numbers are called elements, right? So when you multiply, the wrong thing to do, so this is not how you're going to do your homework, is to take the first element times the first element and make a new one. The second one times the second one and make a new one. Third times third, and fourth times fourth. Okay, this is the wrong way to do it. Okay, this is not what we want to do with matrix multiplication. Can you do this? Like, you just watch me do it. Obviously, it's possible, but this is not the way, this is not what you're trying to learn right now. There are times in real life when you are a programmer, and you've got your MATLAB code sitting in front of you, and you're gonna want to, like, there will be a legitimate reason for you to do this process. There will be times where this process has to happen, but this is not what we're learning. Don't do that on your homework. Okay? Yes, it exists, but you can do that, right? Like, you can multiply. That's not what, we're not trying to test you on stuff you already know how to do. So, okay. If you have questions, you know where to find me. If you don't have questions, you know where to find your homework. Have a great day, you guys. I'll see you in the next video.